Today we're going to talk about how LED works. Many people like to use LED in their Arduino project because they are very useful for debugging and many other purposes. But you can't add an LED without something to limit the current, like current limiting resistors. Today we're going to talk about how the LED and resistors work and why you need them together. First thing, let's look at the resistor here. When a voltage is applied to a resistor, a certain amount of current will flowing through this resistor. It's determined by the Ohm's law. And let's say if the resistor here is 10 ohms and the voltage supply is 5 volts. So we will get 0.5 amps current flowing through this resistor. This is calculated by the Ohm's law, which is, you should remember, is the current flowing through the resistor is equals to the voltage across the resistor divided by the resistance. LED work a little bit different. LED is basically diodes. A key parameter of a LED or of a diode is their forward voltage, which is the voltage that is required for the LED to become conductive, and which is also means no current will flowing through the LED until that much voltage is applied to the LED. Now let's look at this IV curve here. There are two things you have to remember about LED. Number one is if less than the forward voltage VF here, if less than the VF is applied to the LED, no current will flowing through this LED, and it's kind of like an open circuit. Your LED will not be turned on. Number two, if the voltage gets close to the forward voltage VF, and suddenly your LED will be turned on, and it allows any amount of current flowing through it. It's kind of like a short circuit, which is really bad. We're gonna have some issues if this happens in our Arduino projects because it allows drawing unlimited current from the source. It will kill your battery very quickly, and your LED gun burn very bright and gets very hot because you're sending too much current through the LED. Your LED gonna die very quickly too. So what we need now is a resistor to limit the current. Usually, the most LED is designed to run about at 20 milliamps current flowing through it. Let's see how can we design a circuit to make sure your LED and battery have a long lifespan. To do that, we're gonna put a resistor in series with an LED. By putting a resistor in line with it, we can make sure there's not too much current going through the LED. If we have 5 volt supply and we want 20 milliamps current, we want to use Ohm's law to figure out the resistance it should be. And first we can rewrite the Ohm's law here is R, the resistance equals to the voltage across the resistance divided by the current flowing through the resistance. And now we have 2 volts drop over the LED because the forward voltage of the LED here is 2 volts. So it gives us 5 volts minus 2 volts equals to 3 volts here, and divided by the 20 millicurrents, it's about 115 ohms. This is the resistance we need. Of course, you can go higher than that. It will make your LED a little dimmer, and you can also go a little lower than that. It will make your LED more brighter, but usually we don't want to go too much lower because in that way you will draw too much current and hurt your battery life. So usually the resistance we set is equals to 100 ohms or a little bit higher than that. And that's it. You can try it on your 1 to 3D circuits. You can change the value of the resistor, see what's going to happen to the LED. One more thing you have to remember is you have to put the LED in the right direction. Usually the short leg of LED goes to ground. Another interesting thing is when you click the LED on the 1 to 3D, you can change the wavelength of the LED. Then you will get different color. Okay, thanks for watching.